Let's continue where we left off. Scott, we had looked at a horizontal projectile. They had given us T, which was nice. I said we're going to spend most of our time finding time. If they gave us time, it falls apart because we could put time in both columns. And we had found Vx and Vy because, did I say angle components? All right. We had found the height. We had found the range. Now it wants the final velocity just before impact. This is probably the more challenging type of a question. What's the final velocity going to look like? What I said to you was typically I dolp. I pretend it's going to look something like that. Might be steeper, might be shallower, but I'm telling you when it hits the ground, it's going to be going down at an angle. Did I say angle? Then what I do is I break it up into components. Always doing the horizontal first. This is not Vy initial. This would be Vy final or Vy impact, whatever you wanted to think about it. Vx, though, I know. That one doesn't change. Can you look at your T table and tell me what is Vx? It was 17 point something? Point. Excellent. Oh, got a latecomer. Vx I know. Vy final I don't know. I need to find Vy final. You know what? I'm going to do a tiny mini, well, I'm not even going to call it a T-table. I'm going to do a vertical listing of data. So I'm going to say to myself, I'd like to find Vy final. What else can I use from the vertical column on the, oh, well, I know this one. AY was negative 9.8. Did I know Vy initial? That's my way of saying someone go look. I couldn't fit it all on one page, sorry. Ella? Oh, that's right. It worked out evenly. That was nice. And, oh, I also knew time of impact was 5.2 seconds. I could use that. You could use the height that we found using Vf squared equals Vi squared plus 280. The only problem is that always gives you a positive velocity. In this case, I think I'm expecting a negative one. Oh, I can use good old Vf equals Vi plus At. As long as I use vertical, vertical, and vertical, go straight to your calculator. Let's not even write out the numbers. So it's going to be Vi 10 plus negative 9.8 times 5.2. I am expecting a negative answer because I think we are traveling down when we hit the ground. Negative 40.96. So I'm going to add that here. I'm not going to bother putting the negative on my vector diagram. The negative is, Emily, that downward pointing arrow. That's the negative. Ethan, they wanted me to find the final velocity. This is the final slanty velocity right there. How can I find its magnitude, Ethan? Yes, good. I knew you'd come through. I know you're a little tired. Now you're a little more awake. Good. Let's go to our calculator. I had absolute confidence in you, my friend. I'm going to go 17.32 squared plus answer button squared, square root. Do you get a magnitude of 44.5? Or did I make a mistake? That's right, 44.5 meters per second. At, where am I going to put the theta? Top left or bottom right? Color. 40.96. Opposite, yes? 17.32 adjacent. You know what? I think it's going to be tan theta equals 40.96 over 17.32. I have a feeling we're going to get a fairly big angle. I'm just visualizing, because my triangle is not to scale. If I drew it to scale, I think it would be way steeper and a bigger theta. Oh, that's wrong. 67.1 degrees. South of, oh, no, we didn't say south of east. What was the phrase that we used for a side view? What did we say yesterday? Below the horizontal, or if it's on the way up, above the horizontal. That's what we do. So it's going to be below the horizontal. Yes? I would put a little, typically what I do is I mark it right, but almost always I go like this. I just put a frowny face there. Come on. That's not north. Up is not north. Down is not south. So I'll be nitpicky, but not nitpicky for the marks. Question I saw. That's not north. Up is not north. We're looking at the side view. Down is not south. We do that on a piece of paper for convention, but in my classroom, north is the back of the room, south is the front of the room. Yeah, so again, I won't take marks off, but I have to teach you correctly. It's a side view saying south, north, when we're talking about a three-dimensional moving object, we say below the, and that's why I always draw the Vx first, also because we learned that stupid gimmick, who remembers Vy was which trig function? Sine, which trig function was Vx then? Of course it was. You could, as long as you always draw the horizontal first for projectiles, you're fine with that. And the convention is we give our angles with reference to the horizontal, not the vertical. One more, we're done. A projectile is launched from the ground with an initial velocity of 88 meters per second at an angle, did I say angle? Of 70 degrees with the horizontal. You know what? Before I do anything, I think I better dulp. So, there's the cliff. Oh no, it's from the ground. No cliff. That's, wow, slanty ground, Mr. Dewick. And it's launched at an angle, 70 degrees would be way steeper. Probably like that. We have 88 meters per second at an angle of 70 degrees. Okay. Jonah, what's this question going to ask me to find?
The velocity.
Okay. I guess after 4.6 seconds, it's going to ask me to find the slanty velocity. There's a bit of a problem, but you know what? Let's do our no-brainers and our components and our t-tables. We'll feel better, and that might help. We'll kind of percolate the question in the back of our mind. So I'm going to do my t-table over here. Jonah, what two things can I write right away? I usually start with X, but yeah, UBU. Yeah. Vx. Which trig function? Of course it is. So it's going to be 88 cos 70. You know what? There's a 9 right there. I think I'll go 30.10. That's to 4 sig figs. If it wasn't a 9, I might carry one more sig fig, but 30.1, there's an implied 0 there to 4 sig figs, but this is my rough work. I'm not going to worry about including that 0 because I'm lazy but organized. Which trig function is Vy initial?
Sorry.
I have no idea what the answer is. 82, you know what? That 2 is next to a 9. How about 82.693? That's a good place to round off to 5 sig figs. 82.693. Alrighty. Do you remember what I did in the previous question when I was finding a slanty velocity? I dulped. I said, you know what? Don't write this down. Please look up. I said, it's probably going like that. I can't do that here. Can anybody see why I can't just do that? It might be on the way up. I don't know. Maybe I should be drawing it like that. I'm not sure. It might be on the way down. How could I tell whether it was on the way down or on the way up? What would tell me? Initial velocity is 82.693. Mara, what? If Vy finals, not the final, because the final velocity is technically what they're asking me to find. That's the slanty. If the vertical velocity at 4.6 seconds is positive, then I know it's on the way. If it's negative, I know it's on the way. So before I dulp this time, I'm going to walk through exactly the same procedure I did here. I'm going to find Vy final, then I'll dulp. So I'll make a little note. T is 4.5, Mr. Dewick, 4.6 seconds. And I can find Vy final. In fact, it's going to be our old friend, the first equation that we really learned in Physics 11, Vf equals Vi plus At. I think when I introduced it to you, I introduced it as A equals Vf minus Vi over T. I think I did acceleration. It was one of the first things I taught you. But anyways, it's going to be Vf equals Vi plus At. Crunch the numbers. Do you get a positive answer or a negative answer? You know what? I'm going to use my answer button since it's sitting on my calculator right now. So, plus negative 9.8 times 4.6. Positive, yes? 37 I'll go with 37.613. All right. So what am I going to dulp? Slanty down or slanty up? Okay. Again, it might be steeper, it might be shallower. I'm not going to be that fussy, Daniel, but I am going to say, okay, this is the velocity they want me to find. It's going up at an angle. Did I say angle? Components. Always do horizontal first. Oh, and I can fill this one in. The horizontal is 30.1. What's the vertical? Not 82.693. 37.613. And now, Ethan, I'm in familiar territory. How will I find the magnitude? And then I'll shift sine, shift cos, probably tan again in this case to find the theta. And this is going to be above the horizontal. Try this on your own. I'll do it up here. Let's see if we end up in the same place. Okay. So, Raj, if I need to, I can find a slanty velocity anywhere if you tell me the time. I might have to figure out ahead of time whether I'm on the way up or on the way down, but it's a pretty trivial, Vf equals Vi plus At of the four kinematics equations. It's the easiest one to just work with. In fact, you'll notice I got a bit casual, didn't even write the numbers, just went plug and chug. Where for some of the more complicated ones, I'm more meticulous. B says, what's the velocity, magnitude, and direction after 12 seconds? Spoiler alert, it's going to be on the way down. You're going to do the same thing. You're going to find Vy final for 12. You'll get a negative answer, but then it's a repeat. I'm not going to do it because I think you're getting the hang of it, and I want to give you as much time to practice the homework. There's a little comic there you can read if you want to, but your homework. So I already assigned number 1. You can try number 3. I skipped 2. I skipped 4 and 5. 6 is good. 7 is good. 8 is good. I would encourage you to dulp those. 9 is good. 10 is good. If you want a real challenge, so take a look at number 11. I don't think I'm going to give you one this tough. Although this might be an example of a nasty multiple choice that I haven't covered in the lesson, says this: a projectile is launched toward the wall as shown in the diagram below. It looks like 46 meters per second, 28 degrees above the horizontal. With what velocity, magnitude, and direction does it hit the wall? They didn't give you a time, but they did give you a horizontal distance. That's enough information. If you make a T-table, if you ask which way, where do I know 3 things, trust me, you can find what you need from that if you don't panic, if you're just meticulous and clever. Okay? Can you get out the ultimate review, please? That was that big, massive document that I handed out at the very beginning. We're going to cross out some questions that I'm going to say skip. Ready? I think you can cross out number 2. I like number 4. I like number 4. I like number 4. Number 4 is a nice question. 5 is good. 6 is good. 7 is really vague. This gives you an idea of some of the using principles of physics right to explain questions that they talk about. There is going to be one on your test, but I've dropped some serious hints about it, and I'll give you some serious hints about it when I give you the test, so don't panic about it. 7 just says, explain the behavior. I'm not wild about how that one's phrased. I'm going to say skip 7. 8 is good. 9 is good. Yep, there's a velocity, magnitude, and direction given a time. So that's finding a slanty velocity. You can scratch out 10. 11 is good. 12 is good. I like number 13. I like number 13. I like number 13. Number 13 is a nice question. There's a good example of some kind of a boat crossing a river question that I could throw at you. I like number 14. I like number 14. This is what I've told you you should know. I think I call these kind of the physics no-brainers and their consequences. 15, here's again a nice example of so I like 15. I like 15. This would be a good example of an airplane question that I could tweak and throw at you. 16 is good. I like number 17. I like number 17. I like number 17. You can scratch out 18. 19 is good. You can scratch out 20. I just don't like the way it's drawn or graphicked. 21 is good. 22 is good. 23 is good. 24 is good. There's an example of I was going to say a boat in a river, a person swimming in a river, not really a boat. 25 is good. There's a horizontal projectile. 26, 27, 28 are all good. Okay, I told you I'm going to ask you a question about vertical and horizontal components. I'm telling you 29 with different numbers is going to be on your test. In other words, the column 1 will be the vertical component, column 2 will be the horizontal component, multiple choice question. I'll give you a velocity and angle, and I'll say, find the horizontal and vertical component, circle the correct answer. Okay, 30 is good. Oh, 31 is easy. They gave you time, so 31 I like. Yeah, 32 cross out. They used to, on the provincial, the second last question, you had to graph some data and interpret it. I'm just kind of skipping that, even though it's cool. I got to cut corners somewhere. What I want to talk about is number 33. Latecomer Daniel, can you read to me the first 2 words of number 3? So what you're going to notice on these is the last few questions are often going to be labeled scholarship questions. There used to actually be 2 provincial exams. Everybody would write, in Physics 12, would write the first one. It was a 2-hour exam on everything. Then we had a half-hour break. All of us nerds would come back, and we would write a 1-hour exam with way tougher questions. And your score on that exam determined whether or not you got a scholarship. You can try these. Typically, scholarship questions are far tougher than I would assign. You'll also notice they're often worth 10 marks instead of 7 marks, which means they're multi-step questions. So you can try number 33. I'm not going to say cross it out. I'm not saying I like this question, I like this question, I like this question. I am, however, you can cross out number 34. 35 is another nasty one, like I ended with the homework. That also is kind of a scholarship-y challenge question. You can try that. But 36, scholarship question, you can skip that if you want to. I'm not going to check to see if you did that one. But kids were having so much trouble with cliffs at angles, I added some questions. So I like number 37, I like number 37, I like number 38. I like number 39, I like number 39, I didn't add a 40. I added a couple of more cliffs at angles because there's definitely going to be cliffs at angles on your test. So there's 40 minutes left. You got lots to work on. You can work on lesson 6 homework if you haven't finished that already. Lesson 7, I just threw a bunch at you. You probably want to do them on a separate piece of paper. I would DULP for a lot of these. And then you can start to work away at the ultimate review. Remember, for the ultimate review, Raj, what's my website? If you look on Pit Math, where my notes are under block F, I've put a full showing all my steps handwritten answer key. So before you ask me a question from the ultimate review, I'll say to you, have you looked at my online answer key showing all my steps first? If you work through the ultimate review, you will have seen every question on the test in some form or another, except for the one surprise multiple choice that I deliberately have not talked about. Okay? Class is yours.